Welcome. Alright, so what we've got to accomplish today is this. It's the second auxiliary goal for section 2.4, where instead of being given the equation of a quadratic function and writing its graph, or making its graph, we're going to write an equation of the quadratic function if we're given its graph. Alright, and in order for this to make sense, I need to review a couple things with you. And what I need to review is what you can learn about a graph of a quadratic function using each of those various forms. And I'm going to start with turning point form. And so here's a random graph of a parabola, and I just want to remind you what the things are that you automatically know about the graph if you know the turning point form equation, and thus what you know about the turning point form equation if you know about the graph. Alright, and the major thing that you automatically know about the graph of a parabola if you have its turning point equation is you know where the vertex is, right? Or the turning point. That's what turning point form is supposed to do. The values of h and k tell you the vertex. So that point right there would have to be at h comma k. Alright, and so let's turn this around and let's say that you are given a graph and you know the turning point form, right? You know it's according to the turning point. Well, then you automatically know the values of h and k. Alright, so when we're writing equations of graphs, we're going to think about, do we know where the vertex is already? And if we do, we can use the turning point form to help us make the equation of the parabola. Now, the hard part is finding the value of a, but I'll teach you how to do that momentarily. Okay, so what do you know automatically about the graph of a parabola if you have its factored form equation? Well, when you know the factored form, remember what that easily helps you find is where the intercepts are, the x-intercepts in particular. Alright, so if you know the factored form is a times x minus p times x minus q, then you know these are the x-intercepts. And so if I was looking at the graph of a parabola and I wanted to make its factored form equation, well, the quick and easy way to do that would be to know where the x-intercepts are. If so, I would know the values of p and q, and then all I'd have to do is find the value of a, which again is the most difficult part, but it's something that you're going to learn how to do. Alright, and then finally, we need to talk about what you know about the graph of a parabola if you know its standard form equation, y equals ax squared plus bx plus c. Well, if you know its standard form equation, there's really only one point on the graph that you automatically know the coordinates of, and that's the y-intercept. Because remember, the y-intercept for standard form corresponds with whatever the constant term is. That only works with standard form, of course. Now, you can also figure out what the equation for the axis of symmetry is. You know that x equals opposite of b over 2a will give you that, but it doesn't directly tell you the vertex. Now, it turns out that it's most difficult to make an equation of a parabola in standard form to begin because, well, the vertex doesn't get you directly to there. It gets you more quickly to the vertex form. And the intercepts don't get you there immediately. They get you more readily to the factored form. Alright, so this will be the toughest one to work on, and I'll have to show you how to write an equation in standard form. Alright, but we're getting there. Let's go ahead and look at a couple of graphs that we can write an equation of, and just so you get the idea of how it's done. Now, I want you to write down the directions here, but I'm going to use the blackboard to actually do the work. And you can see what we're going to do is we're going to write the equation of the function for each parabola, and we're going to write the final answer in standard form. Now, I'm going to emphasize final answer, even though it doesn't say it there. We're not going to get here immediately, at least for most of the examples. We'll get there at the end, though, and it'll be pretty easy to do. You should take a moment to copy this graph and then go ahead and listen to my instructions on how we're going to write the equation of the parabola that goes along with that. Okay, now when you're trying to determine how to write the equation of a quadratic function for a graph, what you need to do is process the information that's given to you. Okay? In this instance, I'm given two different things. I'm given the y-intercept right there is at 0, 2. But more importantly, I'm given the coordinates for the vertex. Okay, now here's my general rule of thumb. If ever I know the coordinates of the vertex, what I'm going to do is I'm going to use turning point or vertex form to write the equation of the graph, at least to begin. And so what we're going to be doing then is we're going to be using the form y equals a times x minus h squared plus k. And the reason we use that is because when we use the turning point form when we know the vertex, we automatically know the values of h and k. We know that 1 is h, we know that the 4 is k, and so we can write this much of the equation: y is equal to a times x minus 1 squared plus 4. But the trick with this is, how in the world do we find the value of a? Because we can't just leave it as an a. And so here's the solution to that. If you're going to write an equation in turning point form for any parabola, then you need to know the coordinates of the vertex, yes, but you also need to know the coordinates of just one other point, any other point on the graph. And what we're going to do then is we're going to use the coordinates of that one other point, which happens to be the y-intercept here, and we're going to substitute its values of x and y into our turning point form equation. Okay, so we'll say that that x is 0 when y is equal to 2. And so we can make this 2 is equal to a times x minus 1 squared plus 4, except I'm trying to tell you that we're substituting in for x and y, so let's not write an x. Let's write 0 minus 1 squared plus 4. And then you're going to notice that a is the only variable remaining at the moment, and so we're going to be able to find out what the value of a is for this equation. Alright, so we'll get 2 is equal to a times negative 1 squared plus 4. And let me go ahead and subtract 4 from both sides. That'll give me negative 2. And then if I square negative 1, that'll give me 1a. And 1a tells me that a is equal to negative 2. And so once I know the value of a is negative 2, then I know the complete turning point form equation: y equals negative 2 times x minus 1 squared plus 4. Now, that's all good and well, but the directions, if you recall, weren't to leave the final answer in turning point form. They were to leave it in standard form. So let me show you how you would do that in standard form. Let me make some space on the board. Okay, so you notice I changed the heading up here. I said first write it in vertex form when you know the vertex, and then we're going to change into standard form. So I'm going to take this equation and I'm going to change it into standard form right now. And quite simply, I change it into standard form by following order of operations to simplify that expression, meaning I need to square x minus 1, multiply the result by negative 2, and then add 4. So that would look like this then. When I square the x minus 1, I'll have negative 2 times x squared minus 2x plus 1, and then I'll still have plus 4. And then I'll distribute the negative 2 and have y equals negative 2x squared plus 4x minus 2 plus 4. Then I can add my constant terms at the end, and I'll get y equals negative 2x squared plus 4x plus 2. Each of those are representations of the equation for the same graph. And since we are told to write the answer in standard form specifically, that's why we would get this answer right here. Alright, great. Want you to try one where you're given the vertex. And that's the one I want you to try. Remember, you use the coordinates of the vertex to find your h and k, and then you substitute the coordinates of the other point that you're given in for x and y in order to find your value of a. Then once you've got your turning point form equation, change it into standard form. Go ahead. Alright, and so you can see what I've done up to this point. I used the values of h, k, x, and y, and I plugged them all into the standard form equation, so hopefully you can see where all that went. And then I was solving this for a. Okay, so I added 2 to both sides, that's where this 4 came from. I did 5 minus 1 is 4, 4 squared is 16, put that in front of the a, and then the 16a equals 4, a equals 1/4, which means that the turning point form of this equation is y equals 1/4 times x minus 1 squared minus 2. Alright, you have to write the values of a, h, and k in your turning point form equation. Okay, then you got to go about following order of operations to simplify this equation so that it's in standard form. Alright, and so when you square the x minus 1, you get x squared minus 2x plus 1. Distribute the 1/4 and you get what you see right here. And then finally, collect the 1/4 and the negative 2. Add those together, 1/4 minus 8/4, negative 7/4. So there's the standard form and the final answer for the equation of the graph of that parabola. Alright, we need to try a couple more of these, but when the situation is a little bit different. And you can see that for this parabola, there is different information that you know. You don't know the coordinates of the vertex, so you can't really start your equation in turning point form. What you do know are the intercepts, the x-intercepts here and here, and the y-intercepts. And it's really the x-intercepts here that matters for what I'm going to show you. When you're given the x-intercepts, what I want you to do is you use factored form to begin. And the reason that'll work is because if you know the two x-intercepts, then one of those will be the value of p, the other one will be the value of q. And so you can write this much of the equation with just that information. You can say that y is equal to a times, now x minus negative 4 would be the same as x plus 4, and x minus negative 1 would be the same thing as x plus 1. And there you've got everything you need for the equation except for the value of a. Well, that's why the third point on this graph is going to be important, just like the second one was when we knew the vertex. Any other point on the graph, we can use its x and y coordinates in place of y and x in the factored form equation. So, we're going to use 0 for x, and we're going to use negative 4 for y, and then we'll end up with the factored form equation this way with every value substituted for except for a. Watch, it'll give you negative 4 equals a times, and then I'm going to put a 0 in for the x, 0 plus 4 times 0 in for the other x as well, 0 plus 1. And then I can find the value of a. Well, I'm going to have 4 times 1 times a, so that's 4a. So negative 1 is equal to a, meaning that the equation in factored form for this parabola would be y equals the opposite, or negative 1, times x plus 4 times x plus 1. Make sense? And once we know the vertex form, then we're going to just simply go ahead and use multiplication to write that in standard form. Alright, I'm going to multiply negative 1 times x plus 4 times x plus 1. And actually, the way I'm going to do that is to leave the negative 1 alone, and first multiply the x plus 4 times x plus 1 with FOIL, which will give me x squared plus 5x plus 4. Then I'll distribute the negative 1, have y equals negative x squared minus 5x minus 4. That's the standard form equation for that parabola right there. Going to give you one more like this that I want you to try, and then we'll be done with this video. And here is that graph that I want you to write the equation for. Remember, when you're given the x-intercepts, I want you to use the factored form, and you should know your values of p and q using the x-intercepts. And then the coordinates of the other point on the graph can be used for your x and y, and then all those combined can help you find your value of a so that you can write the factored form, so that you can then write the standard form equation. Try it out, see how you do. Alright, now I hope you can see where I substituted values into this equation. I did a whole lot of that. So make sure you notice that where p was in the equation, I put -3, right? And this is minus -3, so I'll put +3. Where q was, I put 2, and since it was x minus q, I put -2. Wherever there was an x, I put -1. You see that was here and here. And in place of y, I put -12. There you see that. And then you can follow the work to figure out what the value of a is. And once you know what the value of a is, this is the factored form of the equation. Alright, great. And then of course we want our final answer in standard form, so let's go and do the multiplication. I would prefer that you save the 2 till the end. It'll make it easier on you. X plus 3 times x minus 2 is going to give you x squared plus x minus 6. And so then your final answer, y equals 2x squared plus 2x minus 12. That's how you write the equation of a graph if it's a parabola and you're given the graph. Okay, there's only one scenario that we didn't cover. I'll show that to you in class because it's going to require, as far as IB is concerned anyway, the use of your graphing calculator. Alright, I'll see you then.